let's continue with the presentation of highlights from the GREENART project. And representatives of this project are David Chelazzi, who has a master's degree in chemistry from the University of Florence, and a PhD in Science for Cultural Heritage Conservation. He is Associate Professor in Physical Chemistry at the University of Florence and the Department of Chemistry. And sorry, I'm missing a few words here, but you know it as CSGI. His main research involves advanced and nanomaterials for art conservation in the industry. I'm sorry, I'm losing my thread. David has been and is involved in various European and national projects on these topics. Other speaker is Bronwyn Ormsby, who's a principal conservation scientist at Tate in London and who leads the conservation science and preventive conservation team there. Before GREENART, Bronwyn was also PI for Tate's contribution to the Nano Restart and Cleaning Modern Oil Paint projects. In all, she has 25 years of research experience into modern paints and the cleaning of modern painted surfaces, and all this made her the recipient also of the very prestigious, I can say, Plowden Medal in 2024 for her contributions to the conservation and heritage science professions. I give the floor to you. Will you be first, David?
Thank you for your kind introduction. And of course to all the organizers for hosting this beautiful event. And also on behalf of all our partners in the GREENART project, we wish to thank, of course, the European Commission for their support in fostering this research and sparking the potential for innovation in cultural heritage and links with other sectors. Now, the GREENART project started in October 22 and ended this last September. It was a large partnership, 30 partners, collecting centers for research, museums, and industries all over Europe and also worldwide. The United States, Brazil, China, Japan. Here's a glance to the partnership, and everybody made a fundamental contribution. It would be impossible now to mention everybody in such a large partnership, but you can see here how diverse it is with museums like Peggy Guggenheim Collection and Tate, just to mention two, or industry like Shiseido, along with conservation and research centers. And I think this was a key to the achievements that we made in the project, to have such a diverse partnership. It was a bit of a challenge to keep everybody together on many different tasks, but it was very rewarding, I think. So, what did we do in GREENART? In GREENART, we propose new solutions based on green and sustainable materials and methods to preserve, conserve, and restore cultural heritage. We work on remedial conservation, we work on preventive conservation, and our main objective was to start from renewable natural sources and even recycled waste, and use this to build new materials. I will try to show some of the main examples and give you a clear idea of what we did. Now, the ambition was not only to set these new materials as standards in the restoration practice, but also to bring on these new materials as models of cutting-edge technologies that can be transferred in other fields like food, detergency, cosmetics, industry. We think this is a way to strengthen the cultural heritage restoration field and give new opportunities. This is only possible if you have such research driven by a safe and sustainable by design approach, which is a rigorous framework that is transversal. It's not just cultural heritage, but it is transversal to the industry as well. And I will show over the next slides, there are clear steps to follow to have this method and this framework. And by following this framework, the materials you develop can then be not only innovation in sustainable conservation for cultural heritage, but spark a potential for transferring in these other industrial fields. And this is a reverse of the trend, because over the past, cultural heritage borrowed lots of materials and methodologies from the food, cosmetics industries. But now we can reverse this trend, and we can design through this framework tailored material, functional material, advanced material for cultural heritage, and then show how this new technology can impact on a broad and wide global scale. Now, the Safe and Sustainable by Design framework has 5 clear steps. It starts from the hazard assessment of the chemicals and materials that we want to use to build our tools for restoring art. Then we have human health and safety aspects in the production and processing phase of the new materials, of course. This is very important. And of course, what about human health and environmental aspects in the final application that involves conservation professionals and curators? And then, of course, the environment, so sustainability, environmental sustainability assessment, and finally, the social and economic sustainability assessment. And this is made from cradle to grave for all the new materials. Now, in the GREENART project, we had several work packages trying to link these SSBD approach from the very design to the end. And so you see we had different work packages for different classes of materials we were producing. I will be listing them over the next slide. But essentially we had 4 work packages dealing with new materials, cleaning, protective coatings, consolidants, and packaging, and sensors, of course. Then these went through assessment by a large group of conservation professionals and museums. Dr. Ormsby will tell you more about that because she was coordinating the assessment group. And then all this was evaluated through the SSBD framework. And finally, what was validated in this way could be exploited. We had different technology readiness levels through the project. I will tell you about that. Like the cleaning products get to 9, so ready for the market. Other parts were now are about 4 to 5. So overall, we have 5 main family of products, like I said. They're all complementary, of course. We always use a parallel with medicine, so you have different tasks to cure our patients, which would be the works of art, and this involves different operations on the works of art, and of course, materials that you can apply directly, materials that you can apply in microenvironments or enclosures to make these enclosures more favorable to exhibit works of art, and of course, sensor to monitor and prevent degradation. I also have a message from Zoom, okay, and it's not flowing. I don't know what's going on. Okay, go back. So, in practice, we had to devise safer solvents, polymers, monomers, surfactants, coatings, sensors, and of course put together all of these in conservation methods. And let me just give you a glance of the achievements through the different work packages. So we had we had a broad set of solvents and okay, surfactants and cleaning fluids, nanostructured fluids, that then we can upload in hydro and organogels, and this is of course for the cleaning of works of art. Then we have several families of consolidants for paint layer and supports, which made it through TRL up to 4.5, and there's lots of room for development. So this is also another key message from our projects. There's so much also room for, you know, promoting these new materials farther and farther. We hope to do so in future projects. New packaging materials, foams, replacement materials, all made from natural-based building blocks. And then, of course, all of this was evaluated through the SSBD. So, as an example, the cleaning. Here you see a typical example of a gel that was produced in the project, something that you can handle easily and apply right over works of art to remove soot, degraded varnishes, and different kinds of unwanted layers. You can upload with different fluids, water, organic solvents, depending on the type of gels. There are lots of possibilities. Now, this technology was built over expertise from previous European projects, and some of these materials already had some good green chemistry scores, but in the framework of GREENART, we either implemented from green to greener or produced completely new materials to replace. So, using this approach, we could get to clean masterpieces like Jackson Pollock, Pablo Picasso. You see here example of surface soil removed in a very non-invasive and time-effective way, which we know is key. And all of this expertise was implemented in GREENART, where we also had examples of modern art, which were very sensitive to traditional solvents and methodologies, so they really needed new approaches. For instance, this beautiful Bridget Riley's works of art that will be illustrated later by Bronwyn. And these solutions were also evaluated by the Solar Impulse Foundation, and we get recognition of efficient solution label, of course, taking into account the sustainability as compared to commercial benchmarks. So this is a validation that states, okay, now we can go on and replace on the market the traditional benchmarks. And like I said, the cleaning methodologies have processed to TRL 9, and at CSGI, which is the Center for Surface Science in Florence, was the coordinator unit of GREENART. Now there will be a new startup building up from these results, and starting in May 2026 to have really these materials transferred to the market. Now let me go through also other very interesting results in other work packages. These are just examples like foam that you can shape around the art using 3D printing, so then you can use this as a mold and build perfect foam packaging for transport in a very safe way. Other examples of coatings, very promising graphene coatings that you can use actually to protect against many different degradation pathways, from oxidation to biopollution, light. There's lots of potential in this area. And many sensors that were built to monitor the classics, relative humidity and temperature, but also organic pollutants that are ubiquitous in many museums and enclosures. All of this was supported by intense dissemination and communication, international conferences, dissemination articles, lots of training events, really hands-on, with professionals in the fields, scientific publications, and of course the precious cooperation with other projects in the cluster, which was supported by the Commission, and then thanks to the work of our colleagues in other projects, it was possible to carry on events and create new opportunities. This is an example of a very important dissemination event we had at the Expo in Osaka 2025, and it was very impressive impact, and I think with a very important double value, because here you see examples of really the citizen touching the new materials produced by the project and having a clear idea how they can promote art conservation. And it's a nice transfer to raise citizen awareness of how important our work is. But also, this was made in collaboration with Shiseido, and it was a very important example of how, if we follow this SSBD framework, we can develop technology that it's really relevant to important industries. And this can be a true this can be key to give really a strong momentum to the research we do in cultural heritage, with a strong social and economic impact. And of course, the clustering activities, otherwise we wouldn't be here today, so they are a fundamental tool to carry on. Now, with this, I would like to invite Dr. Ormsby to illustrate some of our representative case in the assessment of the new material. Thank you, Bronwyn.
Morning or afternoon all. I'm not sure what time it is because I came from London this morning. Is it morning or afternoon? It's morning. Good morning. Thank you, David. I know. So I have the pleasure of just communicating some of the many, many examples of case studies that were involved in GREENART. And I was really only involved in the cleaning work package, so they're the examples that I'm going to bring to you this morning. There were many in the other work packages, and the heritage partners in GREENART were mostly involved in all of the packages, or at least more than one. Tate was exclusively only involved in the cleaning work package. Don't need that slide. Just to put up a few more logos. They are all of the partners that were involved in the cleaning work package, and certainly representing the heritage partners, which I don't use the word end users much, but I call these heritage partners, and thanks to all of them for their contributions, because we had monthly meetings where we discussed the issues we were facing around translation of the new materials into practice, around terminology, around methodology, around ethics, and all the rest of it, all the things that conservation professionals have to bring into their practice. So this is a very boring table, but it just shows some of the different, I guess, case studies across work package 2, which is the cleaning work package. There was a great number of different objects involved, including mid-20th century Morris Louis, Kenneth Nolan paintings, which have problems around oxidation of canvas and also deposition of soiling, and also stains, which are notorious in those works. We have lots of metal objects with degradation products, cumulative materials that are on the surface from many conservation treatments, and life wanting to be removed or reduced, looking at coating removal from metal objects, looking at removal of coatings from works on paper, prints on paper, egg tempera paintings, panel paintings, removing adhesive from works on paper. We have decorative polychrome furniture or artifacts, which have particularly, I guess, obscuring layers on the surface, which needed to be reduced. The aforementioned Bridget Riley paintings, we had a couple of textiles that were worked on as well by the Met in New York. And a couple of the heritage partners actually joined forces. So we had the Peggy Guggenheim collection and the Museum of Fine Arts in Houston, both working on Morris Louis paintings and Kenneth Nolan paintings at the same time in tandem and doing testing in parallel. So this is those, just to show you what they were. representative of both collections, similar problems. You can see the discoloration of the canvases, the stains, etc. Anyone who's worked on 20th century paintings will know that these paintings are problematic to treat, and they have been subjected to quite radical treatments in the past and even in the present. So I think there has been quite a recognised need to find ways forward for these types of works. And the Peggy Guggenheim collection conservators and the MFAH team did a lot of interesting work and a lot of interesting methodology work. All of us got together, we compared different, you could call them benchmarks or established cleaning methods with the new methods coming through in the GREENART project. And we looked at parameters that were relevant to our decision-making processes for the treatment of the actual works. So there was a lot of conservation science, heritage science supporting all of this work, but there was also capturing the empirical aspects that conservators use to make decisions when they're faced with cleaning an actual object. So this is just an example of the methodology they were working with, which I found quite nice. We always like visual ways of assessing things, and the larger the spot, the better the system. And what we have here on this slide is Peggy 5, which is a gel that's come through in the Nano Restart project, which is very efficient and helpful for cleaning soiling off surfaces. And we have 3 examples of the GREENART gels. PVA SA, if you haven't told them what they are, I was relying on you to do that. PVA SA2, PVA SU2, which are decorated polyvinyl alcohol gels with diacid fatty acids. C8, C9 kind of level, maybe a bit smaller. Anyway, he should have done that. Okay. So you can see here they were looking at different aspects, such as conformation to the surface, water retention, water release, transparency, things like that, which are important in terms of bringing new materials into the field and getting people used to using them, but also comparing them to things that they're more familiar with. So here's some more of the results. This is jumping to the kind of end phase. I believe they've started either starting treatment or they're working up a treatment plan for this painting now based on this research. They ended up working with PVA SU2 gel, which is a succinic acid decorated polyvinyl alcohol gel, which is the same gel we used at Tate actually, which I think will probably come to the market. It seemed to be bubbling up to the top of the hydrogels being produced. They were working with a new green chelating agent at pH 10, and of course all of this kind of experimentation leads to the development and the optimization of a conservation treatment proposal, at least, followed by a treatment. So, as I said before, they had both institutions carrying out tests, and they shared mock-ups and they shared methodologies, and they actually pretty much had replicated results across both institutions and the 4 works of art. So there's quite a bit of confidence in these new materials for tackling that kind of stained canvas, cellulose canvas. So we'll see what the treatment brings, but that's very exciting. It's great to have an alternative for these kinds of works. Peggy Guggenheim also did some looking at polyvinyl acetate coating or varnish removal from sensitive modern oil paints, which is also problematic, or removing any kind of synthetic polymer from sensitive paints in general is a very difficult task. So they were working with hydrogels with some of the nanofluids coming through in GREENART, also looking at green solvents with some of the organogels, and again some of the hydrogels with some green solvents. And they were working towards a treatment on this Mondrian painting, I believe, which is polyvinyl acetate coating applied in 1968, which is clearly not intended to be an original coating. So they actually developed a method. If you can see on the top right there, they have a bunch of mock-ups, which is pretty standard practice these days. In that case, it's ultramarine blue, which is a highly sensitive oil paint film coated with polyvinyl acetate, and they worked out a 3-step system, 3 different applications of the gel with a saturated solution of propylene carbonate, which is a green solvent, done in 3 steps. And they actually, as conservators, are so brilliant at working out how to apply and remove these tools, they ended up working with a type of Kim White lens tissue in order to encourage the swollen coating layer onto the tissue to help remove it. So that was exciting for the removal of synthetic polymer coatings from modern painted surfaces. Here we have a very different century of art, 19th century. This is the LACMA, key LACMA case study, which, as you can see, is a decorative altar table with auspicious symbols, indeed. And you can see from the cross-section work carried out by LACMA that it is, on the surface, you have multiple layers of various different natural polymers applied at different times, and effectively that layer had become quite obscuring. So the aim of the treatment here was to reduce that layer to recover some of the decorative features of the object. So again, jumping to what was a very long process of comparative evaluations and optimization, you can see the benchmarks here, which were free solvents, Pemula, and other materials that people might use. We have also some of the organogels at the top right from the GREENART project. The Unicamp hydrogels are actually cellulose-based gels coming from Unicamp in Brazil, which is another form of hydrogel coming through the GREENART project. And on the bottom right are the CSGI hydrogels. And you may be able to see, certainly highlighted in the yellow box there, is that PVA SA2 gel was bubbled up to the top of these tests, and they ended up using that, I think, with one of the nanostructured fluids, the benzyl alcohol-based nanostructured fluid, to reduce that, I guess obscuring layer is the best way to put it. They've also published this treatment, actually, just recently. And something I know a little bit more about is the Bridget Riley paintings. Fall on the left, Hesitate on the right, from 1963-64. So relatively early but quite famous part of Bridget Riley's career, which is still ongoing. We followed a rigorous methodology we've been developing for 20 or so years at Tate around cleaning modern painted surfaces, and also learning from many other people, of course. We developed a bunch of mock-ups based on analysis of the paintings and the layer structure, discussions with Bridget Riley, discussions with her representative, other people, much consultation with interviews and conservation records, etc. We developed a range of mock-ups, as you can see, based on design features of the artwork, but also flat black and flat white areas, so we had a lot of space to test all these wonderful systems with. Again, we kind of did the benchmark thing, but we also looked at application methods a little bit. So free liquid swabbed, spreadable gels, which I think I would call so things like xanthan gum, rigid gels, agarose, gellan, those kinds of gels. And then on the right-hand side, we have the CSGI, GREENART, and PEGI gels. They're all just in deionized water. We were looking at the sort of fundamental properties of these systems as hydrogels. And maybe you can see with these star diagrams that the CSGI hydrogels offer some improvements over all of the others just in its hydrogel state, so not even optimized to the treatment. We went long. There was 500 tests in all before we got to the painting, and this is the slide where we were testing the painting for the first time. We have cleaned both works of art now in the project timeframe. We ended up working with triammonium citrate and 0.5% EcoSurf EH6, which is a relatively eco-friendly surfactant made by a Dow chemical company. It still has an aquatic toxicity profile, but it's far improved. I'm probably taking too much time. Anyway, we were exploring the effect of pH. We also did a lot of swelling studies to support the choice of pH, and we ended up with pH 6. And here, maybe you can see in the middle at the bottom, there is a very much cleaned area on the painting. That's a gel clean with PVA SU2. And again, we spent quite a lot of time optimizing the cleaning system, the application time, and the clearance strategy. And then you can see the SU2 gel on the painting itself after all of that rigorous optimization and risk assessment. We end up doing 2-minute exposures with the gel and 2-minute clearance with the hydrogel equivalent. We were using Mylar templates in this case. We've cleaned other paintings without templates, but in this case we required one. And maybe you can see the before and after on the right-hand side. Cleaning modern contemporary art is quite subtle, but it definitely had a very, I guess, impactful effect visually. I don't know if you believe me now, but on the left-hand side is uncleaned, on the right-hand side is cleaned. And we did a lot of colour and gloss measurement and infrared spectroscopy, all the things we could throw at the surface before and after cleaning. We did a lot of assessment. And the clean painting is far less yellow. The contrast between the black and white is far stronger. The visual energy, which Bridget is really values in her works is stronger, and also the soiling has been removed to a safe level, so therefore it will not further embed with time, which is the main risk of not cleaning these works when you have the ability and the time and the tools to do so. Nothing else we have in our kit at Tate would have done this work, and so we're very grateful for the GREENART project for developing these systems. These gels are quite extraordinary once you learn to use them and to optimise them for your challenge. So thank you very much.
Thank you so much, Bronwyn.